Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. When we talk about physical security, we're referring to anything that we can physically touch, like a lock, fence, or a security camera. Physical security's main goal is to control entry and exits of an area. Some common locations where we might implement physical controls include the perimeter, like at the entrance of the property. Think of a military installation where we have guards and barriers at the gate. Another example is buildings might have security guards, locked doors, and video cameras. Secure work areas are used in highly sensitive or classified areas, and an escort might be required to actually move around the building to make sure the work stays in those areas. Server rooms that house our networking infrastructure might have badge readers to enter the room, and then hardware might have additional physical security controls like locks on server cabinets or cable locks for laptops. Besides what I just mentioned, it's not uncommon to use landscaping to actually help provide security or even just conceal certain parts of the property using bushes or trees. Let's talk about some of the popular defenses that organizations will use to secure the perimeter. Fences are an extremely common security control that we use, and they create a barrier around the property and they deter people from entering the premises. It's also common for us to use guards to monitor these gates around the boundaries so that they can ensure that only authorized individuals can enter. You might have noticed that at high security facilities, they use barricades in addition to some of the other controls that we've talked about in order to keep people from forcing their way through. Bollards are another example of barricades, which are short vertical posts composed of reinforced concrete and or steel. These might be considered less intimidating to normal business visitors, but they're extremely effective if somebody decides to drive a truck through them. Drones, which are unmanned aerial vehicles, are growing in popularity because you can fly them around the property and see what's happening through a camera. With that being said, they're not going to stop somebody like fences, barricades, or bollards will. Lighting is another common deterrent control because we can put it at entrances or places where attackers are likely to try to get in. We might also try lightly dimmed lights or motion detecting lights in combination with sensors, so that way if motion is detected, then the light's going to trigger. Alarms are also useful security control, whether it's to alert on unauthorized access, fires, floods, or anything else that we might be looking for. I already mentioned motion detection, but we can also utilize infrared detectors that can look for temperature differences, so when it changes a whole bunch in the temperature, it's going to alert us. Signage is used to deter people from entering a restricted area, saying things like no trespassing or authorized personnel only, and you should use these as an initial warning to trespassers. Let's discuss some security measures that you can take to secure your buildings. Do you remember the last time that you were at a hotel and you had to scan your room key to enter your room? These are called proximity cards, and they're scanned by a proximity reader. We use these kind of cards in businesses everywhere to secure access. Locations can include front gates, entrance turnstiles, and on doors. Proximity cards are given a charge from the reader to authenticate the user. It's also not uncommon to require a PIN number. That way the user's authenticated with multi-factor authentication, and then we're much more confident about who entered the area. Locks have been around for a long time, and we still use them today. Whether they're standard physical locks, electronic locks, biometric locks, or cable locks, we've got locks. Let's talk about the types of locks a little bit more. First, we have physical locks, and these are the locks that you're used to seeing at your house, and they're the least expensive to implement. Of course, physical locks have their flaws, but it's still better than leaving that door unsecured. Physical cipher locks typically are going to have 4 or 5 buttons with numbers on them. You type in the code, and then the door unlocks automatically if it's electronic, or you'll have to turn the lock physically. Just like regular physical locks, cipher locks don't authenticate the user that's trying to get into the area, but they do require a PIN to actually get access. Biometric locks provide both identification and authentication, meaning that they can tell who's trying to access an area. These locks can use retina scanners, fingerprint scanners, or any other biometric capability. Like anything with biometrics, you need a system that has a low false acceptance rate so that only authorized people can actually get access. And then cable locks are just like you might see with bikes, except they attach to a computer and then around furniture. These locks have either a key or they require a code, and they work well as a theft deterrent. Guards are an effective control to protect physical access to your facilities. Of course, they can check badges or identities of people before they actually get access. Two-person integrity requires 2 or more authorized people to perform an important task. The actual definition only refers to CompTIA or communication security key materials. Even the military implements something called two-person control on nuclear launch weapon systems, where two people have to activate the weapon at the same time. Video cameras are used by organizations everywhere to monitor areas with sensitive data, parking lots, building lobbies, and other areas. These cameras can be great for identifying people if something bad happens, but they can also be used as part of authentication or to minimize how many guards are needed to physically monitor areas. Physical security controls frequently use sensors to detect changes in the environment. Some of the common sensors include motion detection to monitor motion in an area, noise detection in the event that there's abnormal amounts of noise or loud noises, then alarms are going to sound, temperature sensors to detect changes that might indicate a fire or air conditioning failure, moisture detection for areas that are in flood zones or that have water suppression systems that might leak, proximity readers that read proximity cards as an authentication measure, and card readers instead of proximity readers that require a card to actually be inserted for authentication. Once you're physically in a work area that's considered secure, that doesn't mean that you can just avoid all types of security measures. Physical security is extremely important when it comes to our overall protection measures. Let's talk about some important ways to secure specific areas or rooms of a building. Air gap is a strategy used with highly secure networks where they're physically isolated from another computer or network. There's literally a gap of air between them. You might be asking, well, what about patches? And that's a good question, because these kind of networks do increase the amount of work because you physically have to bring in patches and antivirus updates to the system or network. We call that sneaker netting these. Vaults are a room or a large compartment used to store valuables. These can be like vaults at a bank where you protect money, but they can also be used to surround areas like SCIFs or sensitive compartmented information facilities that process highly classified information. Faraday cages are rooms that prevent radio frequency signals from entering or emanating outside of the room. It's basically like a metal cage, and again, some highly sensitive or classified areas have been known to use this kind of construction for their rooms. Safes can be used to protect smaller valuables like encryption keys, backup USB drives, or laptops while they aren't in use. Alternatively, you might be able to use a locking cabinet for the same purpose. Protecting the airflow in a room can also help keep what's inside of our rooms protected. Have you ever been inside of a data center and wondered why one aisle's hot and one's cold? Well, there's a reason for that. Hot and cold aisles help to regulate the airflow and cooling in a data center full of server cabinets. The front of the cabinet sucks in cold air, and hot air is exhausted out of the back. When you go into a data center again, you'll realize that the backs of the cabinets are facing each other and form the hot aisles. Asset management is a process that tracks valuable assets throughout their life cycle. Imagine items like employee computers, servers, or inventory. Effective asset management helps reduce two main vulnerabilities. First of all, architecture and design weaknesses, because the process forces every purchase to be reviewed and approved so that we know exactly what's being introduced into our network. And second, system sprawl and undocumented assets, because it helps us to ensure that we don't have underutilized systems or more than we need. Maybe we have a server somewhere that we can repurpose or share capacity. Many organizations use some type of RFID tracking system for all their assets. If you happen to have a work laptop with a barcode on it, it's likely the tracking barcode for asset management. Physical access is an extremely serious security concern because these kinds of attacks have a much higher chance of causing problems. It's been said that if an attacker can touch a box, then they own it. So these attacks are something that you definitely have to be aware of. Malicious USB cables have been talked about a lot in recent years. These cables have an embedded Wi-Fi controller that's capable of receiving commands from nearby wireless devices like a smartphone. Since computers recognize these as a keyboard or a mouse type device, an attacker could send commands to that computer. Imagine if an attacker can program malware to a cable like this and deliver it to your system. Malicious flash drives are flash drives that are configured to infect your computer with malware once they're plugged in. These aren't really a new technique, and there are stories of attackers dropping flash drives in parking lots labeled with things like company salaries and, of course, human nature. People are going to plug them in. It's possible to configure operating systems like Windows to not automatically run USB flash drives that are plugged in, and I would highly recommend this. Card attacks are something that you might have personally been impacted by without even having worked in IT or cybersecurity. Card skimming is when an attacker can capture credit card data at the point of sale. For example, the attacker installs a skimmer on the credit card machine of a merchant like a gas station. The attacker then records the data on the magnetic strip of your credit card, and the transaction goes through. Broken security seals or loose credit card readers are almost a surefire sign that the machine's been tampered with. Definitely check out the link that I provided at the bottom of the slide about credit card skimmers. Credit card cloning is when an attacker takes the data from your magnetic strip and copies it to a blank card. This is typically when you see fraudulent charges showing up on your credit card. Fortunately, the increased requirement of credit card chip readers has decreased the success of this technique. Even though we're talking about this in the context of credit cards, this can be used against proximity cards if you're not careful. Fires are a real concern when it comes to physical protection of our networks and systems. Whether we use fixed systems or portable fire extinguishers, hopefully we can put out any kind of fire that occurs. In order for a fire to happen, you need heat, oxygen, and fuel that creates a chain reaction and forms a fire. Fire suppression systems try to remove or disrupt one of these elements to put out the fire. They can remove heat with either chemical agents or water. However, with electrical fires, we would never want to use water. They can remove oxygen with either carbon dioxide, CO2, or similar gases. They can remove fuel, meaning that there's nothing left to burn, but this isn't a typical strategy. And they can disrupt the chain reaction by using specific chemicals and thereby stopping the fire. This is a good time to bring up the safety of people. We always want to consider how human safety is going to be impacted. For example, we aren't going to release a bunch of gases if people are in the area. We also need to make sure that if badge readers stop working, that people can still exit the building in an emergency. Network cable routing should always be a concern when planning out your network layout. Literally, if an attacker has access to cables, they can slice them and rewire them in less than 10 minutes, regardless if it's RJ45 Ethernet cable or fiber optic cable. So how do we protect wiring? One way is through cable troughs, which are basically a tray that runs overhead and cables sit inside of them. This allows us the ability to view in plain sight cabling and see if there's tampering. We can also use something called a protected distribution system, which is another strategy where cables are housed inside of a metal pipe called a conduit, and that way an attacker would have to physically break that pipe to access the cables. Sometimes these even have anti-tamper sensors that will trigger if somebody messes with it. This is even more useful if the wiring goes behind walls or above ceilings where we can't see it. The last consideration that you need to have is making sure that electromagnetic interference, EMI, from lights or other electronics isn't going to impact the cabling. One of the things that's guaranteed with technology is eventually something's going to fail. Fortunately, there are ways that you can increase the availability of systems, which we also call resiliency. Two key terms that further describe resiliency include redundancy, which adds duplicate systems and network components so that it has fault tolerance, meaning that if something fails, the system or the network can continue to operate. Let's shift gears and talk about the ways that we can accomplish this. A single point of failure happens when an entire system or network relies on one component, and when that component fails, the entire thing fails. When we remove single points of failure, we're increasing our reliability and availability of systems. We can do this with disks by introducing RAID, servers and networks with load balancing, power with uninterruptible power supplies or UPSs, and personnel by cross-training employees so that if our subject matter expert on firewalls leaves, we have somebody who can step in. We're going to focus on the first three in this section. Disks or hard drives are simply one of the components most susceptible to failure. Redundant array of independent disks, or RAID, is a system that provides fault tolerance and basically could allow a hard drive to fail and still operate and recover. Let's talk about the different types of RAID that you can use. RAID 0 spreads or stripes data across two or more disks. This actually only increases the read and write performance and combines the total storage of the drives together. If you lose a drive in this configuration, you've lost data. RAID 1 is also called mirroring because it creates an identical copy of one disk to another. This means that you can lose one disk and still be fine. RAID 5 is 3 or more disks striped together like RAID 0, but one of the disks has parity information. This means that you can lose one disk and the RAID can still rebuild itself, but if you lose 2, then you're done. RAID 6 is the same as RAID 5, except you can lose 2 disks and it requires at least 4 disks. RAID 10, sometimes written as RAID 1 plus 0, combines the benefits of RAID 1 and RAID 0 by providing mirroring and striping. This requires drives in multiples of 2, so 2, 4, 6, 8, and so on. Disk multipath provides a separate data transfer path to and from the storage hardware. If one path fails, the second path can handle the transfer, or if both are working, then there's an increased performance. This is implemented using something called a storage area network or a SAN system, which is complex and expensive. Some organizations, networks, or systems have a need for high availability. High availability means that the system needs to be up and operational with almost zero downtime. You might have heard of 4 nines or 5 nines of availability, and this basically means 99.99% or 99.999% of available uptime. These are really high amounts of uptime, and to give you an example, 5 nines equals less than 6 minutes of downtime per year. The more uptime or availability requirement that you have, the more expensive it's going to be. So what do we need to ensure high availability? Well, we need load balancers. So first let's talk about what a load balancer is, and then there's 2 types that you need to be familiar with. Load balancers come in both hardware and software, and they essentially distribute data across systems or networks. Some types will send traffic in a round-robin fashion, where others can identify which servers have low utilization and send traffic there first to balance the workload intelligently. If a load balancer sees that a server's down, then it stops sending traffic there. It's also important to note that for load balancing, we typically will use a virtual IP address so that behind the scenes, things can be changed easily instead of having an IP hard-coded, like with a static IP address. Active-active load balancers optimize and distribute data loads across multiple computers or multiple networks. Essentially what happens is all of our load balancers will equally distribute traffic as it's received. Active-passive load balancers work in a failover mode, which means that there's one active and one inactive or passive load balancer. When the active fails, the inactive or passive load balancer is going to take over. This type wouldn't be as ideal for a company like Amazon that receives massive amounts of traffic throughout the day, because it's more likely that the active load balancer would fail or be overwhelmed. NIC teaming allows you to group 2 or more physical network adapters into a single software-based virtual network adapter. This results in an increase in performance. Also, if one NIC fails, the others still exist, so there's no single point of failure. A good example of this is that I have a network-attached storage unit, or a NAS, that I use, and it allows me to group NIC ports together. We need power to operate basically everything. If the power goes out, we need a backup option so that we can keep critical systems going. There's a few common ways that we can have redundant power supplies. Uninterruptible power supplies, or UPSs, are essentially battery backup boxes that give us enough time to perform graceful shutdowns, or they'll at least maintain power until a more long-term solution is available. Dual power supplies are a capability in lots of enterprise-grade equipment, and it's basically the ability to have a second power supply in a server, router, switch, or whatever device. That way, instead of just plugging into one power outlet, we would have 2 in case one goes out. Generators are larger power sources that we can use for days or even weeks with critical systems if we had to. Managed power distribution units are rack-mountable devices that usually have several power outlets, just like a power strip. The main difference is that these kind of units have software or an application interface where we can monitor the status without physically being in the data center. Have you ever lost data because your computer crashed or because you accidentally deleted something? Well, losing data in an enterprise is a serious thing, whether that's critical data, customer data, or data that's required by law. Backups are simply a copy of data in case we lose data, it's corrupted, or if we get hit by ransomware attacks, we can restore that copy. Let's talk about the main systems or mediums that we can use to back up data. The first one is disk, and that's the simplest way that we can back up data, and it involves either using USB storage drives or having additional hard drives on a server. Unfortunately, disks can be expensive and less reliable than other methods. Network attached storage, or NAS, uses a dedicated computer for file storage and makes the data available on the network. This is like buying a Synology NAS device that you can use at home, and the options with multiple drives allow you to configure RAID on them. Storage area networks, or SANs, provide block-level data storage via a full network. A SAN allows for high-speed access to disk arrays or tape libraries, and these are much more common in large organizations. And then we have cloud, where we can store and back up data. This can be done both at the individual employee level and the enterprise level with different services by providers like Amazon Web Services. Let's talk about offline backups versus online backups. Now, offline backups like tapes or local disks allow for easy access, easier control, and fast data restoration. On the flip side, we also have to secure these backups from access, protect them against damage, and they can still ultimately fail. We might call offline backups cold backups because the systems or databases actually have to be offline for the backup. And then we have online backups, which are offered through cloud providers, and they can be accessed anywhere. Online backups also are usually encrypted, and they offer much more robust redundancies with large providers like Amazon Web Services, Microsoft, or Google, just to name a few of the major cloud providers. We might call online backups hot backups because they back up when the system or the databases are operational. Backups are a crucial part of protecting data in an organization. With that being said, there's several types of backup jobs that we need to talk about. Keep in mind that the backup type that you'll need is going to vary from organization to organization. The first backup type is a full backup. Now, full backups are exactly like they sound, and they back up everything based on the criteria that we set. That includes all the files and folders that existed when that backup job is ran. Restoring full backups is pretty easy because we have a single backup file that has to be restored. Unfortunately, the two main issues with full backups are that they can take a long time if we back up large amounts of data, and maintaining full backups, especially large backups, can be expensive. Differential backups start with a full backup, and then only the things that have changed are going to be backed up going forward until a new full backup is completed. To restore a differential backup, you first have to restore the last full backup, and then you can restore any differential backups in the order of when they were ran. For example, if we had a full backup that ran on Sunday night, and then a differential backup that ran on Tuesday night, and then a crash on Wednesday, we would have to restore Sunday's full backup and then Tuesday's differential backup. Incremental backups start with a full backup, and then they back up any changes in data since that last backup, which could be either a full backup or an incremental backup. So let's say, for example, that we have a full backup on Sunday. Then we have incremental backups on Monday, Tuesday, Wednesday, and Thursday. Now let's say on Friday that we have to restore back to Thursday's state because we got hit with a ransomware attack. We would have to restore the full backup, then Monday, Tuesday, and Wednesday's backups. Another situation that could be a disaster is, let's say you created a report on Monday and you didn't touch it again, and then Monday's incremental backup got corrupted. You would lose that report because the file didn't change, so none of the other incremental backups backed up your report. Snapshots, which are sometimes called image backups, capture data at a moment in time. If you've ever used virtual machines, then you might already be familiar with snapshots because you can restore a virtual machine state if something goes wrong. Copy backups copy files to backup media. This is basically like having a flash drive connected to your computer and copying files over. When it comes to backups, testing your backups is almost as crucial as doing the backup itself. Imagine if you went 5 years of performing backups without an issue or testing them, and then disaster hits, but you can't restore from your backups. That's really bad. Test restores allow you to restore either full backups or random files to make sure that everything works as intended. If it doesn't work, then it's great because you've identified an issue before things have got serious. Testing also helps keep your administrators familiar with the process for when something does actually go bad. Every organization needs a backup policy that states what's backed up, how often backups happen, how to test backups, how long to retain backups, and ideally where backups are stored. Storage considerations include offsite storage, for example. It's probably a good idea to have your backups stored in a different geographic location to avoid any kind of weather disasters. Distance where your backups are stored might limit how fast you can get access to and restore your backups. Location selection might be influenced by things like how prone a location is to a disaster or a serious issue. Legal implications might also mandate how backups are stored. Data sovereignty might influence backups because different countries have different storage requirements based on data types and locations.